Is to revisit the idea of what's the greatest common factor of a pair of numbers or a pair of algebraic expressions. What's the greatest common factor? And also looking at what's the least common multiple of something. You probably have learned these terms before, but we need to remember what they are before we start working with algebra. If you have two numbers like that, in some ways you can just look at the number and try and decide what it has in common. You might say, hey, think of some numbers that are called common factors. I mean, this is called the greatest common factor. If you know that two numbers have a common factor, common means they both have that factor, right? Before we look at what the greatest common factor is. If you talk about common factors of two numbers like this, the common factor is you can divide them both by it, right? So what's the first one that comes to mind? Common factors? So let's just make a list of common factors first. You can divide them both by 2. You can divide them both by 12. You can divide them both by, can you divide them both by 3? Can you divide them both by 4? Yeah. Can you divide them both by 6? So there's a list of factors. Is there anything larger that you can divide them both by? Can you divide them both by 8? You can divide this one by 8. You can't divide this one by 8. The greatest common factor is going to be this. Going to be 12. There's a couple different ways you can figure that out if you're not sure how to find that. One way would be to just list the factors of both of them and look for which one's the biggest. Okay? So one way you might have done it, and I noticed some of you were doing this, is to make a list of factors of both of them. So make a list of factors of 48 and make a list of factors of 60. Factors of 48, you can divide it by 1 or 2 or 3 or 4, not 5, right? Can't divide it by 5. You can divide it by 6. Can't divide it by 7. You can divide it by 8. You can divide it by 12. You can divide it by 16 actually, and 24. They should pair up. Okay? When you make a list of factors, they should pair up, and you can of course divide it by 48, right? They should come in pairs that multiply. 6 times 8 gives you 48. 4 times 12 gives you 48. If you know pairs of numbers that multiply to that, 3 times 16 gives you 48, 2 times 24 gives you 48, and 1 times 48 does. Right? They'll occur in pairs like that. That's all the factors of 48. Those are all the numbers you can divide it by. Those aren't the prime factors. It's not what we did when we broke it down to prime factors, but this is one way to do this. What are the factors of 60? You can divide it by 1. You can divide it by 2. 3 you can divide it by. Can you divide it by 4? Yes. Can you divide it by 5? How about 6? Not 7, not 8. What's another one you can divide it by? 10. Remember, they should occur in pairs here, right? 6 times 10. 5 times what? 12, right? What's the next one here? 4 times 15. 3 times, what would that be? 20, right? If you're trying to make a list of factors, you can use the smaller ones to think of the bigger ones. The bigger ones are always harder to find, right? What's that one got to be? 2 times 30 and then 1 times 60, right? So this is one way to find the greatest common factor of two things, is make a list of all the factors and then just look for which one's the biggest one in both lists. What's the biggest one that's in both lists? There's a lot that are in both lists. 2, 3, 4, 6. 12 is the biggest one in both lists. So the greatest common factor is 12, right? That's the greatest common factor of those things. It's the common factor that's the biggest one, right? That's one way to do it. Okay? I'm going to call that method 1, list factors of both. List factors of both. I know that this is not, don't copy this down over here, but you can write it down somewhere else. I'm actually going to write it down here. So this is because I'm very limited with the room up there. This is going to be method 2, okay? Method 2. Break each one down to prime factors. This is kind of a long title. Why don't we just call it use prime factors? You can call the first one list the factors, call this one prime factors. You might like this one better. I don't know. You might not like it as much. If you want to find the greatest common factor of it, if you break it down to prime factors, prime factors means, remember, make a factor tree. Like you could make this 2 times 30. You could make that 2 times 15, 3 times 5. So in other words, we got 60 is 2 times 2 times 3 times 5, right? Okay, those numbers. 2 times 2 times 2 times, or 2 times 2 times 3 times 5. What about the other one? What's 48? Break it down. We got 2 times 24. That's 2 times 12. That's 2 times 6, and this is 2 times 3, right? So if we want to list what 48 is, what's 48? 48, if we put it as a list, we got all these numbers here, right? 2, 2, 2, 2, 3. 4 2s and a 3. If you want to know what the greatest common factor is, just look what they have in common. They have a 2 in common. They have another 2 in common. What else do they have in common? A 3, right? That's what's common to both. Okay, they have 2 times 2 times 3. What's in common? Which is 12, right? That's the biggest common. That's the greatest common factor. So you can do it by looking at their prime factors, or you can do it by looking at just a list of all the factors that they both divide by. Okay, 2 different ways to do it. To find greatest common factor. Now the other thing is the least common multiple. So I'm going to scroll back to one of those questions in that investigate that you guys hopefully again tried. Okay, the other thing is least common multiple. If you're looking at something like that, 12 and 15. Think about 12 and 15. Least, what is it? When you talk about multiples of something, what does that mean? What are multiples? If you say you can only buy eggs in multiples of 12, what does that mean? It means that you can buy, like they come as a dozen, right? Can you buy 7 eggs? Maybe somewhere you can buy them individually, I don't know, but you can buy them in multiples of 12, meaning you can buy 12, you can buy 24, you can buy 36. I realize you could probably buy a smaller thing that has 6, but multiples are if you count by that number, right? You can do this 2 ways as well, right? You can, I would say the easiest way for identifying the least common multiple is just to make a list for both of them. So let's say method 1, list multiples for both. Just like the other one, list the factors for both and pick the biggest one. List the multiples for both and pick the smallest one. So 12, just start counting by 12. Ready? This is easy, right? 12, 24, 36, 48. What's the next one? 60, 72, 84, right? We'll put ... for now. Count by 15 now. 15, 30, 45, 60. Do we need to keep going? 75, 90. I'm going to keep going a little bit here, but you don't need to keep going because you can already tell what the biggest one's going to be here. This is going to be 96 up there, 108, 120, 105, 120, ... Okay, that's a list that's bigger than we need. These are the multiples of 12. These are the multiples of 15. What's the one that's the least, the lowest? The lowest common one. Yeah, there's one in common. This is one in common as well. Right? That's one in common as well. If one person counts by 12s, one person counts by 15s, 60 is the first number they both say, right? Both people say 60 at some point. They also both say 120, but it's not the lowest one. This is the lowest one, right? Right, so you can say the lowest common multiple is 60. If you want to, you can use common factors to figure it out. Okay, here's how you can use common factors, or prime factors. So I'm going to make space there again and call this method 2. If you want to break it down to prime factors, okay, use prime factors. If you want to use prime factors, you can break it apart into prime factors and look what it has. 12, how can we break apart 12? 12 is 2 times 6, and that is 2 times 3, so we got 2 times 2 times 3, right? If you break 12 apart into prime factors, it's 2 times 2 times 3. What about 15? Break that apart? What is that? There's only one way to break that apart. 3 times 5, right? 15 is 3 times 5. The lowest common multiple has to have enough to cover everything here, right? It has to have enough to cover all of those, and it has to have enough to cover all of those. How many 2's do I need the lowest common multiple to have? Has to have enough to account for both of them. It's not what's common to both. If we were talking about the greatest common factor of this, that would be 3, because that's the only thing they have in common, but that's not what we're talking about. Okay? We're talking about what we want a number that both of these can divide by both of these numbers, right? It has to have at least 2 2's because there's 2 2's there. It has to have how many 3's? They each have at least 1 3, so it has to have 3 at 1 3. And it has to have a 5. Okay, so that's what it has to have. If you multiply that all out, you get 60. The lowest common multiple, you got to have enough for both numbers. Okay? If you're using prime factors for 2 numbers, you have to have enough to cover both numbers. Okay? Let's pick one other set of numbers up there and have you try this now if you haven't already tried this. How about we just do find the greatest common factor and least common multiple of 18 and 30, okay? Can you try that right now? I'll pause this. Probably one method's easier than the other. Usually the quicker method's going to be this way, using prime factors. But you can do either way, whatever works, right? If you break them both down to prime factors, you can use that, right? So if I write the prime factors for each one, 18 is like 2 times 9. So we got 2 times 2, 2 times 3 times 3. 30 is like 2 times 15. So it's 2 times 3 times 5. So that's what we have for them, right? If you're using the prime factors, so we got 18 is 2 times 3 times 3. And we have 30 is 2 times 3 times 5. The greatest common factor. The greatest common factor has to be what they have in common. What do they have in common? What do those two numbers have in common? They both have a 3 and they both have a 2. Okay, it's what they have in common. So what's the greatest common factor then? 2 times 3, which is 6. Okay, greatest common factor is 6. Just look back and think about it that 6 is the biggest thing you can divide them both by. Okay? And then if you want the lowest common multiple is not what they have in common. you need to account for everything here. It has to have enough for both, right? It has to have at least 1, 2. They both have 1, 2, so it's got to have a 2. It's got to have, what else does it have to have? It has to have 2 3s, because that one has 2 3s, right? That one has 2 3s. So you got to have 2 3s, and what else does it have to have? And a 5. It's got to cover both of them, right? So what is that going to give me if I multiply all that stuff out? We got 6 times, you multiply it all out, you're going to get 90. Okay, you're going to get 90. You got to have enough for everything here, right? That covers everything. It's enough to make up for each of the things there, right? Okay? You could just do it by listing factors and multiples, right? But for 18 and 30, maybe counting by those numbers isn't so convenient. It's up to you, whichever way you do it. Probably for what we're going to do in this unit, this is the better method, but you can absolutely do it by both methods, right? Don't think this is the only way to do it. Are we okay with that? The reason we're doing this now, again in grade 10, and you probably did this long ago, is because you're leading into, and if you did manage to finish this, you're leading into talking about what's the greatest common factor of things like that. What's the greatest common factor when I'm skipping ahead here to this. What's the greatest common factor when you have some variables there? X to the 5th and x squared? If you broke it down, x to the 5th is like x times x times x times x times x, right? You got 5 of them. And x squared is like x times x. What do they have in common? What do they both have at least? What do they have in common? They both have x times x. They both have x squared, right? X squared is the greatest common factor of those two. You're looking at coming up with greatest common factors of things like this, or things like this. Greatest common factor of those two terms. Can you skip to the end here, and we'll try and do this last question? I know some of you tried to do it and you had a bit of difficulty. Can you skip to this question, please? End of that investigation, if you haven't done it, or even if you have. Guys, listen, okay? You can do exactly the same thing. If you're trying to look for the greatest common factor of those two things, if you wrote them all as prime factors, or think about what it is as prime factors, that'll tell you. 12x to the 4th, if you wrote that out the long way, how would that be written? 12, we already just saw a second ago, it's like 2 times 2 times 3. And x to the 4th, what's that the long way? X times x times x times x, right? That's what 12x to the 4th is. What about 8x to the 3rd? What would that be? It's like 2 times 2 times 2, and then 3x's here, right? This is exactly the same concept when you start to work with algebra. If you're looking for the greatest common factor, what do they have in common when you write them out like that? They both have a 2 in common, right? They both have another 2 in common. We're looking for the GCF here, not the lowest common multiple, right? We're looking at what they have in common, factors they have in common. What else do they have in common? How many x's? 1, 2, 3, right? It's just going to be the lower number of x's. That's what they have in common, so what would that be? What's the greatest common factor of those two things? 2 times 2 times x times x times x, right? Or in other words, what's the short way of doing that? 4x to the 3rd. That's the greatest common factor. That's the biggest thing that you can divide both of those by. Now, a lot of you were asking me when you went and did this, you said, I don't get this question. It says rewrite it as the sum of products, something or other here. What they're saying is write it like this. Write it as something where you have the greatest common factor out here. And what binomial would you have to put in there? Something plus something. What would you have to put in there to get this to, if this was the answer? Okay, so they're saying factor this thing. They're saying take 12x to the fourth plus 8x to the third and break this down into two other factors. Okay? What would you have to put in there if this was going to be the answer, to get that to be the answer? What would this first term have to be here? What would that have to be? It would have to be a 3 to get my 12, right? If I was going to get 12x to the fourth here, what would I have to have as the first term? I'd have to have a 3. And what else would I have to have? I'd have to have one x there, right? Because I got x to the fourth here and I got x to the third there. What about the second term? What would that have to be? If I want it to be 8x to the third and I'm multiplying 4x to the third, what does that have to be? What does that second one have to be? You can just divide it, right? That's what this answer is here. You divide, right? You got to divide. If I want this and I have this, if I divide those two terms, what do I get? Just a 2, right? There's just a 2 there. This thing right here is the factored form of this. It's split into two factors. You can take this single polynomial and split it up into a couple factors. Well, this is more than one factor, but we're going to write it as a group. That thing times 3x plus 2. Those are its two factors, even though the first one is really 5 factors, right? Because there's 5 things on the list. Now, where it says here, I do want you at some point to write something for this. Explain how to factor a polynomial using the greatest common factor. Explain how you can take something like that and write it as, two factors. So what you're saying is you're taking a polynomial and breaking it apart into the greatest common factor times something else. Okay? I want to let you get working on this. You got about 25 or 30 minutes to work on this. We're aiming to get quite far into this section, if not finish this section, okay? All right, can you get going on that?